This video provides a summary of the calculations that you've learnt to date in the aqueous chemistry standard. So the first calculation we learnt this year was how to calculate a weak acid. This here is not provided on the resource sheet, and you will need to know it if you are going to use this shortcut method. So what you do is you find your hydronium concentration by taking the square root of the Ka of the weak acid, and we multiply that by the concentration of the weak acid itself. From there you would need to convert it to pH, taking the negative log. The second calculation that you learnt to do was to work out the concentration of a weak acid when the question gives the pH. In this question, you will need to convert the pH value to a hydronium value. And to do that, you use the inverse log button, which is the 10x button on your calculator. So you put in the negative pH value. So for example, if they give you 5, then you will need to use -5, and then it's inverse log. That will provide you the hydronium concentration. From there, we then use the hydronium concentration, and it is squared divided by the Ka. For a full detailed explanation on how we derive this, you will need to go back to one of the previous videos where the full detail is provided. The third type of calculation is calculating the pH of a weak base. In these calculations, you need the Kb value. To find the hydroxide concentration, we take the square root of your Kb, which is multiplied by your weak base concentration. Once you've got your hydroxide concentration, you then need to convert that to the hydronium concentration. Using the 1 times 10 to the minus 14 for Kw, divide by the value that you got in your first step. Once you've got your hydronium concentration, we then use the standard pH as the negative log of hydroniums. The fourth type of calculation is calculating the concentration of a weak base from the pH. Once again, you need to first convert your pH value back to a hydronium value. So you need to do the inverse log of pH. Once you've got your hydroniums, you need to convert those to hydroxides because we're dealing with a base. So 1 times 10 to the minus 14, your Kw, divided by your hydroniums. Once you've got your hydroxides, it is the hydroxide concentration squared divided by Kb. Be careful because the question may not give you Kb, it may provide you Ka or pKa, and in the next slides I'll show you those calculations. So this here shows you what we have just done in the previous slides. Whenever you are provided the pH value, if you need the hydroniums, you use the inverse log button on your calculator. So it is the 10 to the minus x. However, it is the negative pH value. There will be times, like in the previous slides, where you have got your hydronium concentration and you need your hydroxide value. We use the water dissociation or ionic product of water equation here. This is on the resource sheet. If you rearrange it, the hydroxide concentration can be calculated using 1 times 10 to the minus 14 divided by your hydroniums. There may be times where you want the hydroniums, and to find those, again, you use your 1 times 10 to the minus 14 and divide it by the hydroxides. There will be times when you're provided the Ka value and you will want the Kb. To find your Kb value, we take 1 times 10 to the minus 14, which is your water dissociation constant, and divide it by the Ka. Vice versa, if you need Ka but have been given Kb, again 1 times 10 to the negative 14 over Kb. And finally, if you are provided the pKa value and you need your Ka value, then again we use the inverse log button. So 10 to the x, but we use the minus pKa to get back to Ka. So that summarizes all the calculations we've done to date. I'll see you in the next video.